We all grew up with crayons, spending hours coloring outside the lines, filling blank pages with wild imagination. But have you ever stopped to wonder where they come from? How they're actually made? Today, we're going behind the scenes to uncover the real journey of the crayon. The birth of crayons in America, 1903 and beyond. It's hard to say exactly when the first crayon touched paper in America, but by the early 1900s, the race had already begun. Across the country, companies were hustling to capture a fast-growing market. School supplies, pencils, rulers, chalk, and something new, a small, colorful wax stick that could turn a plain sheet of paper into a canvas. Crayons were about to take off, but back then, there was no single leader. Dozens of manufacturers were experimenting with formulas and designs, all chasing one goal: a crayon that was safe for children, easy to use, and cheap enough for every classroom. Then in 1903, a quiet revolution happened in Easton, Pennsylvania. Two cousins, Edwin Binney and C. Harold Smith, were already in the business of making pigments and industrial goods. But they saw an opportunity to do something different, to create something for children. They combined their knowledge of color with a new wax formula, and Crayola was born. The name? That came from Alice Binney, Edwin's wife. She took cray, the French word for chalk, and mixed it with ola, for oily. Crayola. That first box had just 8 colors, but it was a hit. Bright, safe, affordable, and built for little hands. Over the next century, Crayola would become more than just a brand. It became the face of childhood creativity. Today, Crayola produces an average of 3 billion crayons every year. That's 8 million every single day. Line them up end to end, and they'd wrap around the globe. Not once, not twice, but 6 full times. Crayons are small, a Crayola rep once said, but they make a big mark, in color and in memory. What started as a simple school supply is now a global icon. And while competitors came and went, Crayola stayed at the top of the box. But what exactly is a crayon? What's it made of? And how does something so simple get produced in the billions? To answer that, we have to start with the 2 ingredients at the heart of every crayon: wax and color, raw materials. At its core, a crayon is just wax and pigment. But the way those 2 things come together, that's where the magic happens. The wax used is called paraffin. It's a soft white material that comes from sources like wood, coal, or petroleum. Manufacturers love it for one big reason: it melts easily and holds color beautifully. More importantly, it's non-toxic, safe enough for the youngest artists. Paraffin has a smooth, creamy texture that gives crayons what workers call a nice rub-off. In simple terms, it leaves the right amount of color on the page, not too waxy, not too faint. When the wax arrives at the crayon factory, it's already hot. Tanker trucks keep it at 135 degrees Fahrenheit so it stays in liquid form. If it cools even slightly, it starts to solidify. Once unloaded, the wax goes straight into industrial boilers, where it's reheated to about 82 degrees Celsius. From there, it's stored in massive steel silos, each holding up to 65,000 liters. Enough to fill a small backyard swimming pool. And get this, a single crayon plant can use that much wax in just one day. But wax alone doesn't make a crayon. For that, you need color, and that comes from pigments. Pigments are ultrafine powders that are blended into the wax to give each crayon its unique hue. But it's not as simple as tossing in some dye. Each color follows a strict formula, created by chemists to get just the right shade. Pigments are made off-site. They're cooked, filtered, dried, and crushed into powder, then blended carefully to make sure the final color is smooth and even. Only after they pass quality checks are they sent to the crayon plant. In the last few years, factories have started adding extras, like glitter, scents, and even glow-in-the-dark pigments. These are mixed in just like color, adding texture, sparkle, or smell to the final crayon. One engineer summed it up perfectly. Every crayon starts with science. The fun part is what comes after. And that fun part begins when all these ingredients, wax, pigment, and sparkle, come together in one big vat. Melting and mixing, building the wax base. Once the wax has been unloaded, reheated, and stored, it's time to start making the crayon base. Inside the factory, giant steel kettles, some the size of small cars, are fired up. Liquid paraffin flows into the kettles, where it meets its first companion, clay. The clay acts as a filler. It helps stretch the wax, making each batch more efficient. but it also gives the crayon a bit more strength, so it doesn't snap in half the moment a kid presses down too hard. Next, the mixture gets a dash of synthetic additives. One keeps the wax from sticking to the molds. Another, called stearic acid, improves the way the crayon glides onto paper. Again, every ingredient is non-toxic. That's non-negotiable. Finally, it's time for the pigments. These powdered colors are poured into the hot mix, and everything is stirred, slowly and continuously, until the wax takes on its final shade. Whether it's fire engine red, sky blue, or electric lime, this part of the process ensures the color is smooth, even, and ready to mold. When the mix is ready, it's pumped into a machine called a rotary mold. Here, the hot wax is injected into hundreds of crayon-shaped molds, long cylindrical chambers made from metal or silicone. Immediately after, the molds are surrounded by cold water, which hardens the wax in under 60 seconds. Once cooled, a blade scrapes off the excess wax. This scrap gets collected and recycled back into the mix. Nothing is wasted. One rotary machine can make 2,700 crayons in a single cycle, and with multiple machines running around the clock, it's easy to see how a factory can churn out 30,000 crayons an hour. Each crayon is now fully formed, smooth, solid, and bursting with color. But before they're ready to hit store shelves, they need to be checked, labeled, and packed. And that's where we head next, to the inspection line. Molding, turning wax into crayons. So the wax is blended, the color is even, the mix is hot and ready. Now comes the part that turns that liquid into something every kid knows by heart. The crayon itself? The melted wax mixture is pumped from the kettle into a machine called a rotary molder. It's the workhorse of the crayon world, a big circular device lined with hundreds of crayon-shaped molds. These molds are carefully designed to give the crayon its classic cylindrical shape with the rounded tip. It's not just for looks. That shape helps it hold up in tiny hands. Each mold is filled with a precise amount of hot wax. Then, in less than a minute, cool water surrounds the molds, pulling the heat away and allowing the wax to harden. This part happens fast, around 60 seconds from liquid to solid. Once the wax sets, a blade scrapes off any excess at the top. That leftover wax? It's gathered, melted down, and recycled right back into the process. Nothing is wasted. Every cycle produces about 2,700 crayons, and with several machines working at once, the factory churns out as many as 30,000 crayons every hour. That's a lot of color moving down the line, but even with this level of output, precision matters. Every crayon needs to look the same, feel the same, perform the same. Because for Crayola, and other big manufacturers, it's not just about quantity, it's about consistency. One factory operator put it best: you don't just remember the color, you remember how it felt to color with it. But before these crayons can be boxed up and sent out into the world, each one has to pass the next big test. Quality control begins. Fresh out of the mold, the crayons are cooled, trimmed, and fully formed, but they're not done yet. Each crayon is automatically ejected from the mold and sent down a line where either a human inspector or a high-speed camera system checks for flaws. They're looking for things like air bubbles, uneven texture, cracks, or warped tips. Any sign that something didn't go quite right in the mixing or cooling process. And yes, even one tiny bubble in the wax is enough to send a crayon back to be remelted and recast. It's all part of a closed-loop system designed to keep waste low and quality high. In the early days of crayon production, entire factory floors would run just one color per day. Switching colors meant stopping everything, cleaning every machine, and starting fresh. Not anymore. Today, factories are built for speed and variety. Most large-scale crayon plants dedicate entire lines to a single color, allowing non-stop production, day and night, especially during peak seasons like back to school. The crayons that pass inspection continue their journey, but now they need something small and important: their label. Branding each crayon. A crayon isn't truly finished until it gets its label, the little paper band that wraps around the wax and tells you its name, its color, and its maker. This part of the process might seem simple, but it's surprisingly technical. Crayons roll one by one into a rotating labeling drum. Just before each crayon drops into place, a precision nozzle applies a thin strip of glue. Then, a pre-cut label is slapped on by a mechanical arm. Right after that, A rubber roller presses the label onto the wax. One final robotic arm wraps it around snugly. Firm enough to hold, but gentle enough not to crack the crayon. Each machine can label up to 12,000 crayons per hour, and factories typically run several of these machines at once just to keep up. There's no room for crooked wraps or loose edges. Labels need to stick tight and look clean. And believe it or not, even the labels are color-coded and quality-checked. Any crayon with a misaligned label is pulled from the line, fixed, or sent back to remelt, depending on the issue. As one plant worker joked, "The color gets the glory, but the label makes it official." And now, the crayon is nearly complete, but there's one more big step before it hits the shelves. It has to be packed. Coming up next, how thousands of crayons are sorted, counted, and boxed with machine-like precision, all without breaking a single stick, ensuring every crayon passes the test. At this point, the crayons have shape, color, and their signature label, but they still haven't earned their spot in the box. There's one last checkpoint before the crayons are cleared for packing: final inspection. You might not think much about it as a consumer, but every crayon you've ever used likely passed through some form of quality testing. In factories that produce tens of millions of crayons a week, inspection isn't just a stage, it's a system. Each crayon is gently funneled from the labeling line onto inspection conveyors. These are narrow, vibrating tracks that space out the crayons perfectly so they can be observed either by human eyes or high-speed camera systems. And these machines are fast, scanning for flaws at hundreds of units per second. What are they looking for? Several things. Cracks or chips that happened during cooling or labeling. Bent or malformed tips, which usually point to uneven cooling. Misaligned labels, which may seem minor, but can affect how crayons stack and fit in a box. Color drift, a rare but real problem when pigments haven't fully blended, causing blotchy shades. If a defect is found, the system automatically triggers a gentle air puff or a mechanical diverter to knock that crayon off the line and into the reprocessing bin. These discarded crayons aren't wasted. They're collected, melted down, and reintroduced into the production loop, an efficient, waste-reducing method that's been fine-tuned over decades. Now, here's something most people don't know. Inspection doesn't just happen on the final product. Random samples are pulled from every batch and sent to a separate quality lab within the factory. There, crayons are subjected to more specific tests. Hardness testing, to make sure they don't snap too easily. Color consistency tests, checking that the red in this batch matches the red from last month. And rub-off tests, which measure how well the crayon marks on paper under light pressure. These internal checks help keep the product uniform across millions of units. As one quality supervisor put it, "A kid doesn't care if it came from batch 46B. They just want their red to look like red. That's our job." And it's this consistency that allows major brands like Crayola to keep their promise. That every box, whether it's 8 colors or 120, delivers the same smooth, vibrant experience. So, the crayons that pass these tests now move forward. They're done with creation. Now comes organization. Automated labeling, branding at scale. With inspection complete, the crayons are sorted, labeled, and ready to go. But now the factory faces a different challenge: speed and accuracy. Most people don't think about what goes into putting crayons into a box. But imagine this. In a factory that produces millions of crayons a day, you don't just need to count them. You need to group them by exact color in exact quantities, then gently insert them into boxes without breaking a single one. This is where the automated packing lines come in. First, the crayons are sorted by color. After labeling, each crayon drops into individual color bins, where cameras and sensors ensure they're in the correct lane. If even one stray blue ends up in the yellow chute, the system will catch it. Once the bins are filled, the packing system pulls exact counts for each pack style. For example, a classic 8-pack will get 1 crayon from 8 different bins. A 24-pack might pull multiples of key shades with a specific arrangement. Then, a robotic arm or mechanical plunger gently pushes the selected crayons into a tray or preformed cartridge. The system is designed with soft grips and precision timing, so crayons don't rub against each other too hard and snap. A big risk with large batches. The groups of crayons then move to the box line, where they're pushed into waiting cardboard sleeves, folded, glued, and ready. Most factories use smart sensors to weigh each box before it's sealed. If a box is even slightly underweight, say, a crayon slipped out, a sensor flags it, a light flashes, and the box is pushed aside. Workers can then manually check and fix the issue on the spot. A packaging supervisor once said, "The boxes are light, but the process is heavy-duty." Once the crayons are safely in the box, a print head stamps on important info. Batch numbers for tracking, factory IDs, expiration codes. Yes, crayons technically have shelf lives. Finally, the boxes are bundled, shrink-wrapped, and grouped into larger master cartons. Some are headed to big box stores, others are part of school orders, and many are headed around the globe. But no matter where they're going, they all pass through the same next step. The warehouse. Automated packing lines. Crayon sets. Engineered to perfection. If you've ever opened a fresh pack of crayons and admired how perfectly aligned they were, all in color order, none broken, each label facing just the right way, you're not alone. But behind that satisfying little moment is a carefully designed, fully automated system, engineered for consistency on a massive scale. Once individual crayons are sorted and counted, they enter the packing line, an extended conveyor system where everything is timed down to the millisecond. The system knows exactly what type of pack is being assembled. A set of 8, 16, 24, 64, or even a 120-piece collector's box. Each color hopper feeds into the main line like ingredients into a recipe. A mechanical picker arm or multi-finger gripper collects the right crayons, in the right order, and gently lowers them into packing trays. Some factories use sliding chutes for gentler placement, especially with specialty crayons like glitter or neon, which are slightly more delicate due to their additives. Now, here's where it gets smart. The packing line isn't just counting crayons, it's tracking them. Every set of crayons is weighed in real time. If a crayon is missing, the weight is off by just a few grams. A sensor flags the box, and a robotic arm nudges it off the main conveyor into a correction lane, where a human operator manually checks and adds what's missing. This helps catch rare issues, like if a crayon falls out during the mechanical shuffle, or if a label causes extra friction that slows down a single unit. And while this all sounds highly robotic, there's still a human touch behind the machines. Teams of workers monitor the system at every stage, ready to step in if something jams, breaks, or needs recalibrating. One technician explained it this way: "The machine's the muscle, we're the brain watching over it." After the crayons are placed into their boxes, another set of machines folds and glues the packaging shut. These boxes are then printed with the product code, manufacturing date, and a factory batch number, a kind of fingerprint for tracking and quality control. Then comes the final alignment check. As the boxes move down the line, cameras verify that each one is properly sealed, labeled correctly, positioned cleanly in stacks. Boxes that pass are bundled together in master cartons. These cartons are grouped by SKU and destination. Some are school supply orders, some are headed to retail chains, and others are bulk orders for art programs and international partners. But before any of that can happen, the boxes need to get moving. Which brings us to the final chapter in the life of a crayon: distribution, from factory floor to art room. A freshly packed crayon is colorful, crisp, and factory perfect. But it still has one last journey ahead, and it's a big one. Inside the shipping area of the factory, things start to look more like a warehouse than a production line. This is where all those neatly packed boxes of crayons are organized, palletized, and sent out into the world. First, finished cartons are scanned and moved by automated guided vehicles, AGVs, or conveyor belts to the palletizing zone. Here, robotic arms begin stacking the boxes on wooden or plastic pallets, one layer at a time. These arms are smart. They optimize each layer's orientation to maximize stability while minimizing wasted space. Once the pallet is full, it's wrapped in industrial-strength shrink film, which holds the cartons tight and protects them from dust, moisture, and shifting during transit. A small RFID chip is sometimes attached to the shrink wrap, giving that pallet a digital ID. This tag contains everything from batch numbers to destination data and inventory codes. Now comes logistics. Crayons don't just go to nearby stores, they travel the globe. Crayola alone ships to over 80 countries worldwide, That means coordinating everything from regional warehouses and school districts to retail giants and international freight hubs. Trucks, trains, cargo planes, depending on the order size and destination, pallets might be loaded into climate-controlled trailers or sealed inside shipping containers bound for ocean ports. But even here, there's a system in place. Logistics software tracks every move: when the product left the factory, where it's headed, who ordered it, and when it's expected to arrive. As one logistics manager said, "We don't just move crayons, we move trust on schedule." And eventually, whether it's a big box retailer in Texas, a school in Canada, or a small art supply store in Tokyo, those pallets get broken down, boxes are unpacked, shelves are stocked, and the crayons are finally within reach of their end users: kids, artists, teachers, and anyone with a spark of creativity. And just like that, the journey is complete. From raw paraffin to vibrant wax sticks, from factory lines to classroom desks, from idea to imagination. If you enjoyed this deep dive into how everyday things are really made, don't forget to like, subscribe, and tap the bell so you don't miss the next story. There's a whole world of hidden processes waiting to be explored, and we're just getting started.